Write the rate law consistent with the proposed mechanism above. Rate equals K, H₂O₂. 1 point is earned for the correct rate law. The rate of the decomposition reaction was studied in an experiment, and the resulting data were plotted in the graph below. Visual. Using the graph, determine the time, in hours, needed for the concentration of H₂O₂ to change from 1.50 molar to 0.75 molar, 2, 0.80 molar to 0.40 molar. 1. Time equals 0.71 minus 0.21 is equal to 0.50 plus or minus 0.05 hour. 1 point is earned for the correct time. 2. Time equals 1.17 minus 0.66 is equal to 0.51 plus or minus 0.05 hour. 1 point is earned for the correct time. The experimental data are consistent with the proposed mechanism. Explain. The data show that the time remains constant when the concentration of the reactant decreases by 1/2, indicating that the reaction is first order. The rate law for the proposed mechanism has H₂O₂ to the first power, indicating a first-order reaction. 1 point is earned for a correct explanation. An electrochemical cell based on the decomposition of H₂O₂ can be constructed based on the half reactions in the table below. Visual. Calculate the value of the standard cell potential, E standard, for the cell. H₂O₂ plus 2OH minus gives O2 plus 2 H₂O plus 2 E minus 0.15 V. H₂O₂ plus 2 E minus gives 2OH minus 0.88 V. 2 H₂O₂ gives 2 H₂O plus O2 1.03 V. 1 point is earned for the correct value of E standard. Indicate whether delta G standard for the decomposition reaction is greater than 0, less than 0, or equal to 0. Justify your answer. Delta G standard is less than 0. Delta G standard equals minus NFE standard. Because E standard is positive, delta G standard must be negative. Or, E standard is positive, thus the reaction is spontaneous. For spontaneous reactions, delta G standard is always negative. 1 point is earned for the correct answer with justification. The decomposition of H₂O₂ is slow at 298 Kelvin, but a suitable catalyst greatly increases the rate of the decomposition reaction. 1. Draw a circle around each of the quantities below that has a different value for the catalyzed reaction than for the uncatalyzed reaction. Check delta G standard delta H standard EA. 2. For any quantity that you circled above, indicate whether its value is greater or less for the catalyzed reaction than for the uncatalyzed reaction. Explain why. 1. Only EA should be circled. 1 point is earned for circling EA and none of the other quantities. 2. EA, the activation energy, is less for the catalyzed reaction than for the uncatalyzed reaction. A catalyst provides a new reaction mechanism that requires a lower minimum required potential energy for the reaction to occur. Thus, the activation energy is lowered. 1 point is earned for a correct answer with reference to an altered mechanism.